Good. Thank you all for coming and attending this workshop, which I hope will be beneficial for you. Either you learn something new or you repeat and remind yourself of things that you need all the time. Before we start with content, a little bit of an introduction. So I was asked to join this workshop by Gabriel Ziegler, who was asked maybe by Esra to do such a workshop. As far as I understand it, it's a workshop as part of the CSC, but from my understanding, it's also open to everyone. Everyone essentially, but especially from the Magdeburg neuroscience community, of course. So I guess that's where most of you are somehow from. Before we start, so I'm doing today and tomorrow with an introduction to the kind of basic analysis of fMRI data, as I was asked to do so. And then on Wednesday and Thursday, Gabriel is doing something on predictive modeling. So who am I? I guess most of you don't know me. I'm professor here at OFGU since last year, and I hold the position for essentially research methods in psychology. My background is in neuroscience and mathematics, so I've been doing kind of brain imaging and brain imaging data analysis since, I guess, 2005, 2006. And in terms of research, I'm doing computational cognitive neuroscience. You might also know that under the label cognitive computational neuroscience, but I prefer that. So we are doing behavioral modeling and neuroimaging data analysis modeling, essentially. But today I'm not here to talk about research or the research we're doing, although actually the last part of the workshop will also feature some of the research, because that's then where teaching and research somehow start overlapping, because if you really want to know what's going on, and then you will start to do research. In terms of teaching, I'm basically teaching data science, so I've been teaching cognitive neuroimaging at Freie Universität Berlin, or cognitive neuroscience, but the analysis part there since 2012, where I started before I did the professorship there. And then we started a data science master in Berlin in 2018. And now I'm doing basically the data science curriculum here at the psychology. So we are still in the process of kind of building that up. But if you go to our website and go to Lehre, unfortunately, thus far it's only available in German. So because the teaching at a German university has to be in German, I don't know, and maybe we will be able to change that soonish. But that then needs to go through all the committees at the university, and you can count on the fact that there are some people who will not like that bachelor students are taught in English because it's too much for them. But let's see. Anyway, so we are building up this data science curriculum for experimental psychology and neuroscience. Of course, the Institute for Psychology is fairly neuroimaging heavy. Of course, they have an interest to train students towards neuroimaging, but of course, we have also responsibility to teach and to educate students who want to do research in the clinical sciences. So we try to cover the basics and everything, essentially. Our core curriculum is kind of what you see here. So we have a emphasis, of course, on mathematical foundations, which we do with a 4 course. Then in the first term in psychology, we do probability theory and frequentist statistics. In the second term, we do the GLM, which is also the focus of today's on tomorrow's session. We have long been teaching Bayesian statistics, but currently we will only, I guess, do that in terms of these workshops in summer schools, because it doesn't really fit into the psychology curriculum. And then for the master, we are doing predictive modeling. So anything that's somehow multivariate, although predictive modeling and multivariate are orthogonal, but that's a different issue. And in terms of, so that's kind of the data analytical theory that teaching that we're doing. And then in terms of programming and applications, we have a focus these days on R and Python. Of course, MATLAB for the old school neuroimaging people is also still there. Yeah, so why am I telling you this? Because I invite all of you to join all these things. So if you want to learn about data analysis and the foundations of stuff that you might be doing, always feel free to join our lectures. You find all of them online with videos and the material, but you can of course also attend them in person. You need to figure out a little bit when they are happening. It's usually on Fridays, but you need to figure out when they're happening. So everyone's invited. As I said, it's in German these days, so that will maybe limit it to a certain degree, but anyway, that's what we're doing, and you find on our website, if you go to Dirk Ostwald Lehre, and then go to the summer and winter term, you see what's already there. Actually, the GLM course we'll teach this summer term for the first time in this new setting. That's our website. If you go to Lehre, and at one point there will also be an English version of this, then you find all the teaching stuff. What I'm teaching today is actually part of the CBBS imaging platform, which at this point and for the last 10 years, I guess is more kind of an idea, but one part of the CBBS imaging platform will also be training. And so these kind of courses that we're doing here, I foresee that we will do them essentially every semester break, like a 2-3 day workshop. And if you want to learn about the research that we're doing, you can find that there as well. We have been teaching stuff related to neuroimaging data analysis and data analysis in general for a long time now. And since 2017, we started recording things. You find all of this on YouTube, in YouTube playlists. And just browse around there and see what you find useful and what helps you. But there's a lot of stuff there. So in terms of data science, so before I go into what we're actually doing, I want to give you a little bit of an idea of where I'm coming from and what's kind of the philosophy behind all this. So I see data science as the art of creating meaning from usually digital quantitative data. And in data science, there are kind of these three pillars. So you need the formal language, so math and statistics. You need the applied settings, so you need to be able to program and know a little bit about computer science. And you need to know the field that you're working on, which I put here now as cognitive neuroscience. So I'm not quite sure. We will do a brief introductory round later on, then I know a little bit more where you're coming from. But these are the things that I think all of you who are doing data analysis in the life sciences, let's say, need. And you need to study that because you are data scientists now. The kind of way that I look at any data analysis method is shown here. So for me, analyzing data, that's really what science is all about. So assumption is there is some form of reality, and then we can record data from that. That's actually measurement theory, this process from reality to data. So we'll teach actually for the first time this summer term, because psychologists, or at least old psychologists, I don't know who likes measurement theory, but some people like measurement theory, so apparently, so that's in the curriculum, so I will teach it. It's also interesting, but a little bit limited in terms of its application. Anyway, So, but then anything that you do in terms of data analysis is model-based. And if you are using any form of data analysis, you always formulate a model, you estimate parameters of this model, and then based on these estimations, you evaluate that model. So don't believe anyone who tells you there are model-free techniques like, I don't know what they say these days, but PCA or ICA, all of any data analytical method is model-based. And if people try to convince you that anything is model-free, they just don't know the model or just don't want to pull it down. So there's always a model because you can always formulate how you interrogate the data based on your model. And this will also be how I present the GLM then these days. So we will focus on model formulation and model estimation, and then of course model evaluation. It's kind of inspired by the SPM interface, where you also have these kind of buttons. Any form of data analysis is also a data reduction. So you always start with a lot of data. So if you're working in imaging, you acquire a lot of data, and then you somehow condense that to the figures in your paper and maybe the tables. You do this via scripts that you write, and in the end there's the figure, so you end up with a reduced data set. And if you are not, then you're doing something wrong. So there is this imaging platform and the cluster, and somehow people have a tendency to generate a lot of data, and all the time the storage is full. I don't know what they're doing, but I haven't really had the time to actually start working on the cluster and make that a proper place. So that's something for after this first year of starting the teaching. So that's kind of where I'm coming from, and what's kind of my background, and this kind of permeates all the lectures that I'm doing. So that's kind of the general philosophical spirit there. Here, for these 2 days, we are interested in the GLM for fMRI. We could do something else. We could do free energy principle or variational inference, as I call it, or we could do Bayes, or we could do, I don't know, what else could we do? Measurement theory, but we are doing the GLM for fMRI, which hopefully is interesting for some of you. This is the typical SPM figure. So for those of you who work with SPM, you might have seen something like that. That's from these SPM courses. We will not talk much about all the pre-processing. I will briefly discuss pre-processing tomorrow morning, but very briefly. So that's something we are not dealing with. We are focusing on formulating general linear models. What are general linear models? Essentially, how they are used in neuroimaging for fMRI data analysis, and how they are then interrogated specifically in SPM. Can we close the window? I mean, maybe it's not completely Corona conform, but I guess you in the back can hardly hear me. But you can also, of course, join here. So that's kind of, so these 2 parts here, that's what we will be dealing with. Yeah, let's see then what happens. So this is the outline. So of course, I don't know anything about your background. I will ask you in a second, but I had to design, of course, this course without knowing anything about your backgrounds. I like to start from foundations. So I'm not a big fan of toolboxes and showing people how to use toolboxes without them understanding what they're doing. I start with foundations. So the first session will be on matrices, because if you don't know matrices, then everything is lost. And basic calculus or computations on matrices. Then we need to talk about the multivariate Gaussian distribution to be able to actually formulate the model, which is the GLM. And in the session on the GLM, which will be today's afternoon, I will present the GLM and how to estimate it and how to evaluate it in general. And then tomorrow morning, we start with adapting the GLM for fMRI, so typical task-based fMRI data analysis. And then we will discuss 2 kind of more advanced topics in fMRI, GLM analysis, namely covariance, components, and topological inference, which is this random field theory stuff, which is kind of, so the fMRI designs, that's what you see everywhere. The covariance, components, topological inference is kind of also everywhere. It's of course fairly influenced by the SPM approach, because that's what was built in the 90s and is still there, and is also not maybe that easy to get into if you're new to all of this. So everything is available from the website. There's a link here. I don't want to click on it now. If you have you seen the website? Who has seen the website? Go to Dirk Ostwald. Now, Google Dirk Ostwald and go to the CVBS imaging platform at our website. Maybe I click on it, but I don't want to click on it. I'm afraid of Mac. It will destroy everything. So you could go to CVBS imaging platform, training, introduction to fMRI. You can't see it. What's on the screen, you don't see it there. But has anyone found it? Okay.
What's
okay.
the initial website? What's the initial website?
Go to my homepage.
Yeah,
somebody found it. Okay, you found it? Yeah. Okay, so it's findable via Google. It's on the psychology website. So if you don't find it right now, maybe ask your colleague. It's just if you Google my name and go to the homepage, then you go to CVBS imaging platform and training, and then you're essentially there. So there you find all the material. There's a script, which is the script that I developed for the Scan Master at Freie Universität Berlin. And I think it's fairly easy to find. And you find the script there, and you find the lecture slides there. Also these, you find the Python code, and you find the Markdown code that I used to generate these slides, so everything is there. The videos will also be then uploaded there if everything works out in terms of the videos, which I hope it will. So you have all the material. Then some general reading recommendations. So everything that I will discuss here and much more you find in the script. Really a lot more you find in the script. But I also recommend that you read good books. Depending on your background, if you never had a course on linear algebra, you should study a course on linear algebra. Here are some two references. So Strang is a classic, and Searle is specifically for statistics. You need to get into probability theory. So I think a very good starting point there is the De Groot book. My personal favorite these days, I think, is this German book by Schmidt. For the GLM, also Searle, specifically also the variance component book by Searle. So that's kind of GLM and basically linear models in any kind of probabilistic data analysis. For fMRI, if you haven't started reading any fMRI books, so for beginners, definitely the Hüttel book is very good, and the Poldrack book on functional MRI data analysis, so to get a first overview. And then to get more into the details, I think, of course, the Friston Statistical Parametric Mapping, this red book, is okay-ish. So it's with SPM, it's always been the problem that they didn't really put much effort into teaching or whatever, so it can also be quite confusing. Better in terms of the didactic point of view are the Ashby book. And this Umbao book I just recently, I think 2017 is, maybe it's true, but I don't know, maybe it's a typo. I recently just came about in the preparation of this course. It doesn't look too bad. So that's what you should study next to your PhD studies. Good. So that was already the introduction. Now, of course, I'm also interested in hearing a little bit about who you are. So for the people online, can you briefly just put into the chat, because I can't hear right now, into the chat basically what you studied. So I'm really interested in your background. So bachelor and master degree, and the project, roughly the method that you're working on right now for your PhD, and maybe also where you work. And if you have any other questions regarding the course, also put them into the chat. And the same thing we are going to do here now. So first, are there any questions regarding the setup of the course before we do a brief introductory round? Is there anything unclear in terms of the material, where you find stuff, or anything? Everything's clear so far? Okay. Any questions regarding what I already presented? So I will talk for some time, but then I will always ask you if there are questions. Of course, you can always also ask questions in between some, or when I'm currently telling you something, but maybe I then say, maybe wait a second, because it will come in a second or something. So yeah, just ask questions, because that's an opportunity. Okay, then I suggest, as you now know a little bit about me, that you briefly introduce yourself. So essentially name, your background, and so your academic background, and yeah, in one sentence or two, the project that you're working on and the methods that you use and where you are doing that. Let's start there.